record the session. So I have to redo that session now. Regarding Python, I think we have uploaded almost all sessions except last week's session. So uh, that's the FYI, friends. Right, I think you can. We'll start it. The others might come and join. No problem. We almost discussed about collections. So this is what we are doing in the last session, and this one side is not related to our. So we had done set in the last session. We had discussed about set collection, the importance of set, all that we discussed in class, the methods of set, and then and also set operations like that union, intersection, all that we had discussed in the last session. Yeah, this one. And the important characteristics of set, all that we discussed in the last session. There are so many. These are all very useful scenarios. But what we do is we'll cover a few of these questions related to interview once we are done with these sessions. So that's fine. We did mathematical operations, that is done. FrozenSet is a simple topic, friends. It's not really something, shall we say, important, because I doubt people use this topic FrozenSet. But still, let's have a quick idea. Just let's discuss this for 5 to 10 minutes and complete this as well. But we are not using it much in today's programming or today's project implementation. This is not that much used, friends. Just keep in mind. So the question is, what is FrozenSet? Like a set, this is also one more type of set here. The difference is FrozenSet is a legacy one. Legacy means it was introduced in 1.x version of Java. Sorry, Python. So when this is introduced means 1.x. So there are versions of Python. So, but these are something which were introduced in the very beginning. So this is much more outdated, we can say. And that is what we call FrozenSet here. Now you can see here. So this is how we can create a FrozenSet by using this method FrozenSet itself. We can create this FrozenSet. So if it is set, we can create like this. If it is FrozenSet, we create like this. That's all, friends. And the difference between set and FrozenSet is maybe if people ask a question, what is the difference between set and FrozenSet? Simple. Set is mutable. If we say, so the simple difference is set is mutable, right? I'll just write here, or maybe we can write here otherwise. So when we talk about the difference, set is mutable. You know what is mutable? We can modify set, but FrozenSet is immutable. FrozenSet is immutable. That's why we don't have much methods to do operations on FrozenSet. Like set, if you see, we have methods like add method in set, or many more methods like all these set operations, all this right now, this remove method, pop method, discard method, all this were there in set API, in set class API. But in FrozenSet, we don't have any such methods, right? Because FrozenSet is immutable and we don't modify it. So that's it, friends. So right, that is the difference here. So if you ask a question, so what's the difference between these two, Manora? Simple. Set is mutable, whereas FrozenSet is immutable, and you cannot modify FrozenSet. That is the difference. And how do you create FrozenSet? Simple. We have this class FrozenSet. From this, we can create this this frozen set object. Right. So this one, the method, by using this method frozen set, we can create this one. Right. So to this, we have to pass some iterable object, this method. So we just simply created a list here, and that list we are passing to frozen set, which will actually create a frozen set object from list here. Right. This is the simple idea. We can test it quickly. You can see here. So let's just have a quick test on this as well. So where is this Python? So let's create a simple this thing. One more folder uh, directory we can choose, and then it's like frozen set. Okay. Under this, what we do is we can close all this. These are not needed, friends. Not needed anymore. Under this, what new Python file? Just create a simple file. So some frozen set basics. Just simply because we don't have much here. If there is a small typo, okay, we can correct it. No problem. Refactor rename. Frozen. Okay, that's it, friends. So now we can copy this code here. We just created a simple frozen set. We'll test this again after just simply testing this first 3 lines of code. Then we try to add some element to the frozen set and see if this is allowed on frozen set. As this is immutable, we cannot add element to the frozen set, but we try to see that. Okay, but that we'll see once we just test this these 3 lines of code first. Okay, so this is not the Python comment. Hash is Python. Okay, so now let's run this. So what did we do? We simply created a frozen set object here by using this method frozen set by passing list as as iterable object. Usually we are very clear with these methods. These methods always accepts iterable objects. If you want to build any related object of that, suppose if it is set frozen set, then it accepts any iterable object. It's not like it should be list. It takes tuple, it takes dictionary, it takes set, anything. It accepts anything, friends. It's not like it should be only list always. Right. So then we are just trying to check the type here. Okay. So what you do is just try to print it. So that gives more clarity and more idea here. So print this frozen set. Okay. So now, right, you can just quickly test it, run it, and see. You can see the class here is it is showing as what is this, friends? Here it is showing as frozen set here. So that is the idea. Suppose, so this is the quick understanding. We just created a simple code snippet here, code block, just to create a frozen set object and verify if it is a frozen set class or not. So when we look at the output window here, we can see the class that is created as a frozen set. So that itself is a clear idea for us. Okay, that is fine. Next after that is, so we are very clear that frozen set is immutable. So let me just add that point here. So what is it? Frozen set is immutable. Immutable means, what do you mean by that, friends? We cannot modify frozen set, but still we are just testing it because we are just testing if it is true, if it is immutable or not. So how do you test? Try to add some element to this frozen set, like, excuse me, friends. Right click and then save this one. sorry, uncomment this, and then run this, test it. So if it is immutable, let's see, you can see now. Frozen set object has no attribute add. It doesn't have a method add itself. So we don't have anything. We cannot modify this frozen set object because it is immutable. Suppose you see, let's just show you, let me show you. You see here, frozen set dot. You don't find many methods here like we see for set here. You can see except this operations union. These are all basic set operations. So these are there. This doesn't make any difference to that frozen set. It doesn't. These doesn't modify. But whichever methods do some changes to that object, those methods you don't find here in this frozen set class API. You can see there, right? You can't see that add, remove, pop, or discard. All these different methods which do some changes to that frozen set object that we don't see in this frozen set API, friends. Is this clear for all of you? These things we already had discussed on set. You can apply the same, this union, this is subset difference, that you can test it yourself now because this is discussed in the last session as well. So this is not something really new for us. We already did this. So maybe you can give a try for that. Copy thing, this we did this number of times. This is not something really new for us. Okay. So what you can do is try to do this copy thing as well. Copy just creates a new copy from existing one, right? So that is this copy. So that's all about this frozen set. So this is a clear idea about our proof that frozen set cannot be modified, and these methods don't exist in frozen set except few of these methods, this set operations, and then as a few methods like copy. That's all. And you can apply that length, all that on this frozen set as well. That generic methods you can apply. So you can see you can apply this. So print of ln of fh. You can try these methods as well. This and right click and then say. Now you can see it is giving us this one max min. I believe you can also test with this max method, min method. All this you can apply now. Max of this one, these methods, and then min of fs. Okay, all this. Now you can see here, and similarly you can try. I doubt we can apply sorting on this frozen set. Okay, but maybe you can give it a try if you want. But still, I don't think it will work. So you can simply say sort. It's giving us sorted, but we have sort method sorted up. Okay, let's try this. Pass fs comma reverse equal to. You can just leave it like this otherwise. And then maybe you can print your frozen set object after sorting. So here you can remove the length thing. Just print frozen set after applying sort. I doubt sorted will work really. Right. But you can see again, internally, sorting is happening. You see here, but this sorting doesn't work directly. Again, if you ask me a question, so this is doing, you can see, where is the sorting? No, sorry, sorting is not applied at all. You can see here. This is still an unordered list, even though sorting is applied on this frozen set. You can see this is an unordered list. So what we do is let's print it before sorting and print it after sorting. So that itself gives us a clear idea. Okay, let's run it now. You can see here, before sorting, this is the frozen set. After sorting, this is the frozen set. And both are unordered list here. So these are not sorted. You can see here 40, 10, 20, 30. And also one more important thing. Uh, Even though you apply sorting, that cannot be updated on this frozen set. So point is simple, friends, because in set and frozen set, these elements are stored by using hash code. So elements are, inserted according to hash code. And even though you apply sorting, that sorting don't have any impact on that. So that's why even after it didn't throw any error, that is the point. But after doing sorting, applying sorting, you can still see this. This is an unordered list here. That sorting doesn't have any impact on your frozen set. That is the point here, friends. Okay. Sorry, friends. So that is the idea. So that's all about frozen set. I think this should give you a clear idea. Suppose in case suppose you face any interview questions, what is the difference between set versus frozen set? If you see this kind of questions, but now you can answer most of these questions. Okay. And also there are few other interview questions: set versus list, set versus dictionary, list versus dictionary. People ask a lot of questions on these collections. And also sometimes they ask you programs to do in the interview, a quick program. Like I see some of our friends asking me that they have attended some interview and they have this question. So you have to prepare for all that, but no problem. We will try to cover up that after this. So this keeps going. So all this, because the idea is to make sure that we are really clear with everything, even from interviews perspective as well. That is the idea. Okay, friends. So what is the difference between set and frozen set? Right now, our point of focus is this one: set and frozen set. So what is the difference here? Simple. Set is mutable and you can modify set, but frozen set is immutable. You cannot modify frozen set. So set is mutable. So that is the point. Array set is mutable and frozen set is immutable. So that is the idea. And frozen set is introduced in 1.x and set is introduced in 2.x. That is the other difference, of course. You can just Google it if needed. So that is the so just a simple quick info on this set and frozen set, right? So that's the idea, friends. So what do we do? We'll jump to the next topic. So the topic is, what is it, friends? That is this we did with frozen set. Range thing we had already discussed. Operations. These are all some quick miscellaneous topics actually. Break thing. I doubt break directly work like this in Python because break has a different way of implementation, friends. So maybe we can quickly cover this because these are something useful for you for doing this test actually. So this quick test in your code. So let's see this now. So but before that, I hope you are clear with this frozen set thing, right, friends? So we are done with this. So let's jump to the next topic. Operators. This is okay. This break thing we didn't discuss. So break means what? When you are iterating a loop, and if you want to break that loop in the middle, then we apply that break. Break, as name says, it breaks the execution of your control statement and comes out of that particular block or that particular construct. Okay, so this is the quick idea. So that's about break thing. This is one kind of control statement break, and continue is another kind of control statement. So let us quickly test it. How much? I doubt this will work, but still let's because there is Python has a different way of implementing break. Let's test it. So and just have a quick idea. So I'm just naming this as a break test.py and adding this simple code snippet where this code runs from 1 to 9. So you know, right? When you say 1 comma 10, it iterates through 1 through 9, 1 to 9, and 10 is excluded. So that is fine. And the idea is once if I reaches 5, then we should break the execution of this code block, this loop. We should break this execution of this for loop, right? So but till that, maybe you can just do a simple print of 5. This should work for us. Okay, let's run this and see how this is going to work. So what break does here? Simply break, just simply speaking, it will stop the execution of or break the execution of that particular loop. Break will stop the execution of a loop. As name says, it will break. It will keep a break to that. Put a break to that. That is the meaning of break keyword or break statement. Let's run it and see. 1, 2, 3, 4. I think this is working here. You can see here. So after four, once it reaches 5, this loop got terminated. You can see this loop is working fine. Maybe you can print something after this loop. Still, that would be work. But we put break only for that loop here, and that loop gets stopped or that loop gets terminated. Only loop here, it gets terminated once it reaches 5. That is what break does. Break will terminate the execution of a loop once it reaches that condition. That is the idea about break. And maybe you can just add that simple statement here behind here. So let's run this now. And you can see, we can see the end. Means other statements in the program gets executed, except only this break is applied only in this loop here. That too, when this condition is met, then we should stop the execution of that loop. Once it reaches 5, we should apply a break. So that's how break works here. I hope this is simple and easy to understand. So that's the idea, friends. Right. So understood now. Let me again run it and show you. So what's happening here? This loop actually this loop should iterate from 1 to 9. Otherwise, we put 11 here, 1 to 10. This iterates from 1 to 10. This whole loop, because from through range function we are passing elements from 1 to 10, 1 to 10 here. We're asking to iterate 1 to 10 here. That's what the range is doing here. But here inside we are applying a break. When this break should work, once it reaches I reaches 5, it has to stop. So that you can see after printing 4 elements, it is stopping once it reaches 5. And after that, you can see that whole loop got exited. The execution of loop, this is the whole loop. This got exited. Exited means it is terminated from execution. Only this particular loop. Right. So that is the idea. So what break does? Just it just break the execution of that particular construct, loop construct. So that's all. And other statements will execute as is. You can see the AND is running as usual in the program. When you put a break is applied only for that block of code, not for the entire program. Just keep this point in mind, friends. So this is the idea about break. So let's jump to the another topic. So that's all about break thing. I hope it's clear to understand. That's all, friends. Understood now? You can give a quick test. You can give a try for this code block if you have some time. I'm just sharing this. Where is it? Okay, that's about break. Next one. Continue. This is something many people have a confusion about continue. What is this continue? Let's just quickly test it. I'll explain this in the here in this window itself. Okay, let's add one more program here. So new Python file and then continue test. Okay, let's just test this code. What is the meaning of this continue? Until 5, you can see here until. So this again, this loop iterates from 1 to 10. So how many elements it iterates? It iterates from 1 to 10. This is the thing. This is what this loop does. It iterates 1 to 10, friends. That is the point. Next one. And then you see here, what is the condition here? Until I reaches 5, your control should not go down. It should not go down. Continue means once this condition, as long as this condition is true, this if is true, it goes inside and execute continue. When this continue is executed, then the control is not allowed to go to the down, as is not allowed to go down. Control is not allowed to go down. But again, from here, when we say continue, the control is written back to the beginning of loop. Again, it's just try to take one more element. Again, it comes inside. It will take next element comes into the loop and execute this condition. And then again, it's say continue. As long as we say continue, the control is again is not allowed to go down. Is not allowed to go down. It's just a continue means again we are saying to the control just go up against go to the start of the loop and try to iterate on the next element. So that's what we are saying here. So maybe you might ask, maybe you might ask, Manoram, we are not still clear. Can you debug this and show us? Let's do a small debug. You get a clear idea. It's a simple thing, but there is a lot of confusion for many of our friends on this. The continue thing. Okay, what we do? Let's do a small debug. That itself gives you a clear idea. But what is the functionality? How this continue works? Unlike break, this doesn't break or terminate the execution of the loop here. This block of code. This does not break it, but what it does, whenever continue is executed, the control is immediately written back to the start of the loop. That's it. And it doesn't go to the bottom of go to the bottom, or it is not allowed to go to the statement after continue. So is that point clear? Suppose there is this print. So when you say continue, your control is immediately transferred back to the start of the loop, and this statement is not executed after continue as long as continue gets executed. Suppose in this code, if I say I less than or equal to 10, so in this thing, in the whole journey of this block, okay, this print never gets opportunity to get executed. Why? Because this loop iterates from 1 to 10, and in all those cases, this never have an opportunity to get executed, because in all these 10 cases, this continue gets executed. When continue is executed, control from here, from line 3 is again written back to line 1 to the start of this loop. And the statement at line 4 will never get a opportunity to get executed. Excuse me, friends. Is that clear? This should be very clear for you. So what is this continue? Continue continues the with the next iteration, simply speaking. Once we reach continue, it won't go to the next statement after continue, but just asks your program to continue with next iteration. But still you ask me, this should be very clear for you now, because the output itself shows us, like suppose you see here, let's run the code and later debug it again. So you see here, friends, let's run it normally. You can see first five elements are skipped here. You can see as long this condition is true, the sprint never get opportunity to execute. Why? Because as long as this condition is true, continue gets executed. Once the continue gets executed, control is immediately returned back to the start of the loop. So this won't have opportunity to get executed. That's why you don't see the first five elements getting printed here, but you can see elements got printed from 6 onwards, because by that from 6 you can see this condition is true only until when I is 5. So that's why this print gets chance to get executed from 6th element onwards. So that is the idea. I hope this is clear. Okay. So this is clear, right, friends? So now what we do, let's debug it so that you get a much more clear picture about this, the code snippet. Let's run this and send and then say debug this continue test. And you know how to do this debugging thing. So what is that? These are all different options. Step over, step into my code, and this is step out, all this. And this is a return to cursor. Which one should we choose? We can choose step over, right? So what we do now, let's start with this. You can see it started with the, you can see here, I is 1, iteration 1 started. And then what we do, we just say step over. Now it came inside this continue. You can see that the continue came inside when I is 1. So sorry, that control came inside to this if block, and that got and continue gets executed. When continue got executed, the control is again written back to the start of the loop, and this statement didn't get any opportunity to get executed. Let's run it again. Now you see you are at this condition check. This is obviously true. And then it came to continue. Then what happens? If it is continue, do you think the control is allowed to go to this print statement after continue? I don't think so. Maybe if you have a doubt, this should give you a clear picture now. When you just say this, see here, step over, what happened? Again, the control is transferred to the start of the loop. It is written back to the start of the loop, but this print statement didn't get any chance to get executed. So that itself is a clear idea. Now you see all the 5 times, once it reaches continue, again the control is written back to the start of the loop, and the statements after that continue will never get an opportunity as long as continue gets executed. So let's test it. See, third time you can see we came to continue. Once continue is executed, again the control is written to the start of the loop. You can see there. It has moved again back to line 1. Again, now we are at the 4th iteration. Now we are at line 3. Continue gets executed. When again you see now when this gets executed, the control again written back to the start of the loop, which is line 1, which is at line 1. So this should give you a clear idea. Again, you can see here we are at iteration 5 and it came to continue. Again, when if it is at continue, definitely this control is again written back to the start of the loop, friends. So let's see. So what happened now? It has gone to 1. So finally, we have successfully completed all the 5 iterations, right? Now I is 6. So this time this condition is false. So the continue doesn't get executed. So the control comes to line 4. You can see this now. Now print has opportunity. Right. So now run this. Now you can see some output at the bottom somewhere in the console. You can see 6 got printed here. Okay. Anyhow, this keeps continuing now. Now again, this is false because I is 7. 7 is less than or equal to 5 is false. So again, 7 gets printed after that. So you can see here, once that print is executed, 7 is printed here. Similarly, same thing happens for the rest of the loop, friends. Okay. You can see all that 10 values gets printed here and the program got terminated. So this is the idea about continue. I hope this should be very clear for all of you friends. Right. That's all, friends. That's all about continue thing. Is that clear, friends? Now, another one. Once we are done with continue, we will switch to the next topic, that is pass. These are all transfer methods, like the different control transfer methods, like applying break and then applying continue, applying pass. All these are, and they are useful in your coding. Definitely, when you implement some code in some project, these are all useful transfer methods. So that is the idea, friends. So what is pass here? Pass is something simple one. This is not like break or continue, but simple. What it does is it's simply just it is like a filler. Suppose you have some kind of construct code construct. If you don't want to do anything, suppose you just need to. Sometimes there are cases where we just need to just leave it like that. We don't want to print or we don't want to do anything. We just want to just leave it like that. So there should be a filler, but because if you don't put any statement under control structure and under these state control statements, it will throw error. Suppose you here I didn't add any statement under if. Okay, don't consider this as part of if. This is not part of if. This is inside loop. Okay, both if and print are on the same level. So nothing is inside if now. Suppose if you try to run this, you can see here, you see an error indentation expected an indent block for what? For if. It is expecting something for if here. So this is the and your interpreter is expecting print might be something which should be part of if. That is interpreter expectation. But we didn't add anything under if. And I don't want anything under if, but I just want to just simply pass it, like instead of continue, instead of break, I just want to fill it with something. Then pass is something which is the best option we can use in Python. So what do you do? Right click and just run this. We get the same output. You can see here. So what is happening? So this time, this if block is getting executed and print is also getting executed. So right, but still, of course, this is the nature of this one. But what you can do is maybe you just want something only printing from 6 to 10, like in case of continue. One thing what you can do is if you want to just keep it like you can add this print under else block here. And in the first 5 iterations, until this I is equal to 5, right? We should just simply just pass it. We don't want to do anything. Just leave it as is. Otherwise, then we should print rest of those elements from 6 onwards. So this should work pretty well for us. This should work as expected. And this will print elements from 6 onwards. You can see here from 6 onwards, not this first 5 here. I don't want this first 5. This should get just skipped there. But that is one thing is we can apply continue. And second thing, this is the pass option is the best option. So what do you do right now? Right click. Now you can see this time we just got elements printed from 6 onwards. And in the first 5 cases, we just fill that if block with pass means we are asking to do nothing here. So like we say pass in some cases. So do you want coffee or do you want something? Somebody, if someone asks, you say just pass. It means you don't want it. So like that, this pass is introduced in Python just to do a filler job. It doesn't do anything, but we can just do a quick filling. Even though we don't have anything here, this pass itself is saying to the interpreter that you can continue to validate this even though we don't have any other statements under this block. So this is the idea, friends. I hope you are clear with this now. This is the quick idea about pass keyword. Pass is acts as a filler, and if you don't want to do anything under some block of code, if you just declare pass, that pass is something which helps us to do that filling job. That's all, friends. This is the quick idea about what is it, pass keyword. Now we are able to understand all important transfer keywords in Python. So most of the break is one thing, continue is one thing. I don't think people ask much questions on these things, but just an idea for you because these are useful in coding. When you do implement any code in your project, these transfer keywords are very useful for you. So this is the idea about what is it, this transfer keywords. Okay, then what do you do right now? Input and output, we had already discussed that how to have dynamic input from keyboard that is done. So file operations, what we do is go to the functions first and come back to the file operations. So what we do is we will discuss functions because that gives more understanding that is something which is important. Then we will get back to files again. So that is the idea. So what we do now? Another very core concept of Python, because if you have a clear idea about functions, and then understanding OOP becomes much more easier for us, right? So clear, friends? Just a minute. I just want to check if we are, where is it? Like last time, don't want to have a problem. Yeah, we are recording. No problem. So now, if you want to get a word view, like what we hear, means something, a deeper view of OOP, object oriented programming. The base for OOP is functions. There are two things, of course, data and functions, like variables and methods, what we say. Functions are nothing but methods, right? And understanding functions is one of the very important thing to get a deeper idea about what is it, OOP. Because without methods, you cannot expect a class. Of course, you can write a class, still that won't be efficient without methods or functions. So these are all like, the core thing for OOP. So what we should do is let's have a very deeper understanding of functions, right? So that's the idea, friends, and come back to files and maybe we can work on files again. So we'll have a detailed discussion about files as well. One of the very useful topic. Again, we deal lot of things with files in Python programming. So we'll talk about it. But the idea is now I would like to cover functions. So what is a function then? Simple, friends. A function performs a specific task. What is a function? Function performs a specific task, like, or specific task in sense, like if you want to implement some logic, some business logic, like, or if you want to implement some presentation logic, or if you want to implement some database logic, then the best idea is implement those logics with functions. So that is the idea. So functions are nothing but they are used to implement some specific task, or instead of the task is something like implementing some logic. Like that logic can be a business logic. So what is that we have inside function means you might have something like a business logic, or you might have something like presentation, like UI logic, presentation logic, or you might have something like database logic, something like this. You might use functions to implement any kind of logic. So that is the idea about functions here. Is that clear, friends? So that's the a quick understanding. So function is used to implement a logic. That logic can be a business logic or presentation logic or database logic. In fact, this helps us to modularize our code. So what is the other advantage of functions is a function helps us to modularize. Modularize means what? It's nothing but we can break down into parts instead of writing a very lengthy code. We can break down that code into small parts, like small chunks of code. So that is what we call modularization. We breaking down a large program into small parts is called modularization. The advantage with modularization is it helps us to reuse the code. So when you have a modularization, when you break down that code into small parts, so the advantage is the reuse. It helps to reuse that code. That is the idea, friends. So that is what function does. Another important thing is function helps us to modularize a code here, and this helps to reuse your code block. Excuse me, friends. It helps us to reuse that code. So that is the idea about this one, friends. Another important use of functions is this next one. And again, what is there inside function? Function has simple, it's have some group of statements inside that. It's like a small subprogram or collection of statements. And these statements are reusable and performs a specific task. That is the idea. Right? This should be very clear for you. So that is what we discussed in the last two statements even. So what function has means it's just like block of code with some statements inside that which are reusable and perform some specific task. Right. Anyhow, we'll see many examples, and from that examples, definitely you'll get a clear idea how function works in our program. So that is the idea about functions, friends. So is that clear for all of you, friends? So this is the a quick understanding about functions in a nutshell. What is it? A function is something which performs some kind of logic or which implements some kind of logic. It might be a business logic or presentation logic, database logic, or some other kind of logic. And in a way, we can modularize code with functions, right? That is the idea. And these are all advantages what we have with functions. What is it? Code reusability. Yes. Code readability. Readability means having some, like, a neat way of representing code. I mean, something which, if you implement more functions, it's easy for your peers to understand, your colleagues to understand the code you have written. Because even if all of us are working on same project, everybody should be able to understand your code. So that's understanding your code in easy way is called readability, right? Modularization means breaking down large code into small chunks is nothing but modularization. And then when you have functions, definitely it reduces the length of code because all that repetitive code, redundant code, something which we declare again and again, we can avoid such code with functions. So functions reduces length of the code because we do this lot of times. So whenever we see that we are declaring same statements again and again, the best idea is keeping those statements inside a function so that you don't need to declare them again and again. So that is the idea. So when you keep that redundant or repetitive code into a function, then obviously the advantage with that is it reduces length of code. That is another advantage with functions. So that's the idea, friends. Next one, debugging means suppose you have some issues So when you have functions named in your program, debugging also becomes easy for us, right? This is one more advantage. So these are all different advantages what we have with functions. Hope this is clear for all of you friends. So this is the quick idea about advantages of functions. Right. Let's just jump to the next topic. Now we are almost at the very beginning of this introduction to functions. So we got a clear idea now, friends. What is that idea? Simply speaking, the idea is just a minute. Hope this is clear, right? So what is function and advantages of functions? All that is discussed. Now types of functions here. Let's have a quick idea. Generally, when we talk about functions, we have two types, built-in and user-defined functions. When we say built-in means all. So by now, we are very much familiar with all this built-in functions because we had discussed a whole lot of collections. In almost all those collections, we see different methods that are there in each class or each API of that collection, like add method, remove method. Likewise, we have seen at least some 50 to 60 or more than near to 100 methods we had discussed in that collections, right? So those are all built-in methods. Built-in means predefined. We don't need to do anything. We just need to know what is that function name and the purpose of that function and how to use it. I hope that is just a minute, friends. I'll just try to connect my charging. We are running. Okay, friends. Let's continue. So this is the idea, friends. So generally, we have two different types of functions here. So built-in thing, now we should have an idea like all that functions that are available in our Python API, all those are built in. Like this min, max, ID type, add, remove, pop item, many more. All this, whichever is built in. So all that are nothing but predefined. All those are built-in functions. And here we don't have we don't have much to discuss about built-in, but our focus is on user-defined functions. So today's session, maybe today and tomorrow, we are going to focus or cover more on user-defined functions because mastering this is very important for us. Built-in anyhow, we don't have much to do with built-in. They are developed by someone. We just need to understand how to use them. That is okay, that is enough for us. But user-defined is not something which is there already. You have to create your own functions. You have to add your own logic. You have to execute them by a call by yourself. So everything is done by yourself. So that is user-defined function. So what is the user-defined means? Unlike built-in, these functions are not created by someone. If it is built-in, these are developed by someone. We just use them. That's all. But user-defined, we create them and then we add some logic and then we test them. So that's what user-defined functions are. So these are developed by developer and based on your requirement. So that is user-defined. And usually we have two types of user-defined functions. One is default, the other one is parameterized. You can see here. Of course, both are almost same. If you ask me, we don't have big difference between default and parameterized. Why? The way function works is same, but there will be parameters to parameterize. The default don't have parameters. That's all. But we'll talk about it in detail. So that is the idea, friends. Should know what is the idea? When you talk about function, we know what is a function by now. Simply speaking, it's nothing but we keep some group of statements inside a code block, and that is what we call a function, simply speaking. And we do have two types of functions here, default and parameterized. And what is default here? Let's start with default first, okay? Default means simple friends, a function without parameters. We don't have any parameters with the default function. So again, you ask me a question. You also have observed so many default functions so far. As we had discussed, we have covered many of this built, I mean, this collections, all this stuff, the string class, all this, many of built-in classes. You are already aware of this. You already know that what is default. Default means something without any parameters. Like for example, the best example is this pop method. You can see pop don't take any value if you remember. So this is a default method. So default method means something which don't accept any value. A method without parameters is a default method. Anyhow, we'll understand much with the syntax and examples. Okay. So now, so that is the quick idea. Next one, how do you declare functions in Python? See, the function is almost same. The way we declare function is almost same in C or CPP or in Python. But there is a slight difference in Python. It is much more simpler in Python compared to C, C++ or Java and C Sharp, right? So this is the idea, friends. What is it? So we use the keyword def. Def means define. In fact, we use the keyword def to declare this function in Python. So def is a keyword which helps us to declare a function in Python, right? So that is the idea, friends. But before that, what is a default function? It doesn't have any parameters. Just remember, we'll talk about it. And now this is the syntax for a default function. It's simply speaking, we just have function name followed by parentheses. And inside this parentheses, we don't have any variables here. And if you don't have variables inside this brackets, then it is a default function, friends. I hope this is clear. Then before the function, you can see we have declared this keyword def, define. Means this is how we should declare a function in Python. I hope this should be clear for you, friends. And under that, we have to keep statements, put some statements. Is that clear? So this is where you have to add your code block. And anyhow, this is Python, right? So everything has to be done with indentation, unlike in C, C++, Java or C Sharp. We should not use that opening and closing braces here. So this indentation, all indented lines of code under this function are treated as function block. So that lines of those statements under function is treated as a block. I hope this is clear, friends. So this is the idea. So what is a function? Function without parameters is default. You can, this is the syntax. So you have to declare diff here and then the function name followed by parentheses, no variables inside this because this is default. And then statements, whatever you want to declare under that function, put it under that keep that under that function name. So this is the syntax. Let us see an example. A simple example is this. See here. So you can give anything, some meaningful name to this function depends on the kind of logic you implement in that function. So give a meaning name to that, meaningful name to that. And def will always be there. But this name changes, this function name changes from one function to another one. And inside that, you have to declare your code block, all that statements you want under that function. And in this way, this helps us to reduce repetition of code or redundancy, friends. So that is the idea. So I hope you are clear with this, right? Just see, we'll start doing some, we'll start executing some few examples. So I hope you are clear with this now. So this is how we declare a function here, friends. Understood? So that def follow, we are following the syntax. We are not doing anything really new here. So that def keyword followed by some function name, and then that parenthesis empty because this is default, and then the statements you want under that function. So that is the idea. So this is how we declare a function. But if you just declare function, that is not enough. What is that you need? You should know how to call a function. So without calling function, your function never gets executed, friends. So the important thing about functions is, even though how much our big function you declare, or how much our the important function you create, if you don't call it, it won't work. How beautiful code you write in that function, or how complex code you write in that function, or how much big it is, that doesn't matter without calling. So once you declare a function, you should call it. How do you call it? It's a simple thing. Just call that function with function name and that parenthesis after that, because this is default. If it is parameterized, you have variables in this parenthesis, and while calling also you should pass values based on variables you declare here. We'll talk about it when we come to this topic. So this is the quick idea about default function. We'll see a few examples, right? That gives you a quick understanding about how to create functions in Python. Okay, let's do it now. So what we do now, I hope this introduction is clear for all of you, right, friends? Are you good with this stuff? So please let me know. Please let me know if you are clear, or if you have any doubt on this. Please confirm in the chat box, friends. Any confusion or any doubts, you can please ask me. Else we'll jump to the examples now. So we had discussed so far about what, friends? About this functions. And then we are talking about default function. In the default function, again, we have seen the syntax, that is step 1. And step 2, how to call that function. We are discussing these two things here. Right, let us see a small example now. But before that, are you good with this? Right? Thank you. Thanks for confirming. Let's see a small example. So let's create one. What we do? Create one folder for functions, new directory. Let's put folder for functions, and then I put all this under collections, no problem, because they belongs to collections itself. So under this functions, add one file, Python file. Default functions, you can say default functions .py. In this, what we do, we just create a small code snippet. So here, friends, just a small first one, step 1. Creating a function. Just follow the syntax. What is that? Def. You should, your function should start with def. What is the problem now? Problem is, what is the problem for which we create functions? Problem statement. So hello world of function. Hello world. Simple hello function. So def, you can see hello Just give something. See, this is functions are user defined. You can give any name you want to that function, but generally a meaningful name is always recommended. I hope that is clear for you, friends. So what is it? A meaningful name. So hello and then parenthesis and colon. That's all. This is function header. This is function heading. So this is what function heading or header. So that is done with at line 4. Def always should be there with any function in Python. And this name you can give as per your requirement. And parenthesis should always be there with function in any language, no matter whatever language it is. This parenthesis should exist. I hope this is clear. No. So that is the idea. Next, under that, we have to add a code block, something like print. This time, we are not doing much, but just adding a simple hello world. So here, we just say hello world here. So that's all, friends. Done. This is a simple program, friends, with just one line of code in that function. But we'll just try to increase that level of this thing on that functions, level of complexity, or I mean the number of lines of code in that functions, friends. As we go forward, we'll do that. But as we are in the very beginning, you can see we created a simple function with one line of code inside that. You can see here, right? So, but this won't work if you run this. Nothing comes out of this exact program. Why? Once you declare function, next thing is what is this? Calling function. Without calling, it won't work. So what shall we do? How to call? What is the name of function? Hello. Copy that and paste it here. And then even you should put parentheses. That's all. Like in other languages, you don't need any semicolon or you don't need anything else here, friends. Not needed. I hope that is clear. So that is the idea, friends. Calling function. Once you call this function, then definitely this time you can expect some output from this function, this hello. Why? Because you are calling a function. Right. Step 1, you should declare function. Step 2, you should call it. Now you run it. Step 3, execute it. We got hello world here. Do you want to see the execution flow? How this control jumps from call to caller? This is call. This is function call, what we call. This is function call. And we can also call this as a caller, right? Sorry, called function. So this is function call or caller. We can call with any of these names. And this block, this is what? This is a function altogether. And we can call this as, sometimes we can also call it as called function. So these are all quick terminologies, friends. Even if you don't want to remember, you can ignore it. No problem with that. But quick idea for you, that's all. So this is fine. Now, when you run this code, what happens? We got the output. What happens here? So first execution starts from where? Does it start from this function or will it start from calling? Always function call gets executed first, not the function. First, when you have a function declared in a program and you have a function call, always function call gets executed first. Line 8 gets executed first, and then the control go to the function, and then it will get into that function and execute those statements line by line, because we know this is an interpreted program. Python is interpreted, right? So that's how this works. Maybe for more clarity, what we do, we put a debugger and we try to debug it so that you get a clear idea about this execution flow. Now you can see when we run this program in debug mode, we are at line 8 now. We are at color. You can see that. And all that special variables are loaded. At the same time, you can see, right? You can see your hello as well here. You can see this hello gets, this is the hello function, and this has some, what do we see? This hexadecimal address of that function. Here, even functions are objects in Python. That's why function also has address here. This is the address of your function. This is hash code of your function, otherwise, which is in hexadecimal form. So this function got created internally while loading that function itself. But this won't get executed until you call. So let's do that. Now you are at line 8. So now when you say here we have all options now. Now which option should we use? Should we use F8 or F7, or again this Alt Shift plus F7, or Shift F8? Which one we should use here? This time we don't use F8, but we use F7, friends, because this is a function call. Now you need to step into that function. So then from here you have to step into that function. So which one should we use here? We should use step into, not step over. If you say step over, you can see it just, we don't see the control jumping to the function and executing that function, and control coming back to the again caller. We are not seeing all that that control transfers between this caller and called function, or this function. We are not seeing all that. We are missing all that in the tracing, in the debugging. Why? Because F8 just simply steps over to the next statement, but it doesn't try to get into that function. So if you want to step into that function, then you should choose this one, this debugging option. So right click, then say run, not this one, sorry friends, debug, run in debug this thing, debug mode. Now you should see, don't apply step over, but run in, say step into. Now you see the control jumped from hello to this function here. And then it has gone into that function block, and it is waiting at print function here. Now when you say again step into, again that gets executed, you can see in the console somewhere that hello world get printed, and the control is written back again to the caller from wherever you call that function. Again control, once after this function gets executed from here, the control is written back to the caller here. You can see here. Right? This is how the control jumps happens between function, caller, and function. So I hope this is interesting, right? So this is what you need to understand, how this function getting executed internally. I hope this is clear to all of you friends. Now, so that's the idea. That is the idea about what is, how to declare function, how to call a function, what do we call this function call, what is this function, and how this control jumps happens between this caller and function. Right? This is the idea. I hope you are good with this, friends. Next one. So that's all about simple program. What we do is we'll create one more function program. We can close all this. We don't need this, all this here. Now create a new program for functions. What is that program? Right click and just say, so let's create a small program. You can try all this now. So here you can write a program for function to find sum of two numbers using functions. So can you try these programs? Why don't you try? Why don't you rewrite all this with functions here? Whatever we have done so far, we can implement that code with functions, friends. Okay, so what do you do now? I'll just share this problem statements for you. Can you please write code for this simple problems? So sum of two numbers, area of a triangle, area of a rectangle, area of circle. That itself gives you a clear idea how to create functions, default functions. So this time try to work with default functions. Don't try, no need of, what is it, friends? No need of parameterized. For now, you try to implement default functions. Next, after this, we rewrite same programs with parameterized functions. That itself gives us a clear idea, like how these functions work. Okay. Okay, friends, can you give a try on them? Because we don't know how to create function, how to call that, all that. Just you need to add some business logic inside that. That's all, friends. Anyhow, I will try to show you as well. Okay, just take a minute and try to implement, and I'll also show you them. We don't wait, we don't wait for much time. Just giving you some time so that you might try. Okay, friends, what I'll do is I'll try to show you because these are simple programs. So we don't need to think much about this. And let me just quickly solve these problems. Okay. So first thing, sum of two numbers using a function. Just come here and just right click and you can just create what? Simply sum function. So what do you do right now? First define your function. So what is it? Sum function, because I'm creating a sum fun because we have a built-in function sum. I don't want that conflict between the built-in one and our user-defined one. So I put it as sum fun, which means sum function. Or you can create like some func, so that makes more sense. Okay, right. Next one. To find sum of two numbers, minimum two variables are needed. Either you can read them from keyboard or you can directly initialize. You can choose any of these two approaches. It's up to you. So what do you do right now? Something like A equal to 10 and then B equal to 5 and then C equal to A plus B. So that's all. And then print it. Print. Okay. So the sum of okay, A and B is C. Yes. And then dot format, you can pass A, comma B, comma C. Okay, this should be fine for us. So that's all, friends. We just need to pass. So we have three placeholders and we are passing three variables here, and that's all. And we close this. This is enough. So this is a simple function with a simple business logic, which is a sum logic, mathematical logic inside that. Okay, friends. So what do you do right now? Once this function is created, excuse me, friends. Right, all this we did this many times, right? So this code inside function is not something really new for you, friends. This code is not new for us. But what is something what we are just adding a small wrapper to that code. This code, whatever we declared, sometimes something which is in the beginning, we just keep this code inside this function. That's all. So this is how means function acts like a small wrapper to your code. And now what you do, simply make sure the indentation is followed properly. Don't try to do a calling from inside function like this. Like, if you do this, it's like calling a function by itself and it leads to some error because this is an infinite calling. It's called recursion. You are trying to make this function a recursive function, right? And even if you put here, it won't work. For first time, you have to call this function from outside and later onwards, recursion starts. We'll talk about recursion at the end of this function topic. Okay. Now, what do you do? Just call this function. Just keep that caller simply with that function. You just copy this and put it here and just run the program. That's all, friends. Okay. So this we have step one, we created a function. Step two, we are having a caller. You can see here. This is the caller and this is the function. This is the sum function. And step three, what should we do? We should run this code, run it, right click, run sum function. You can see the sum of 10 and 5 is 15. You can see here, friends. I hope this is clear for all of you. So this is the idea. This is the idea, friends. I hope you understand this. So this is how we create any kind of function there. Not the most difficult one or the complex one. The concept of function is this, but that code, whatever the code gets inside that function might change from problem to problem, requirement to requirement. But the approach is this. This is how we create functions. Even the parameters doesn't have a big difference, but almost same. This is the idea, right? But this is very useful concept, like, because the whole OOP depends on these functions. Of course, data is also very important in OOP, but along with data, without functions, there is nothing we do with object-oriented programming. So my humble suggestion is try to understand these functions as much as possible here itself, so that OOP becomes very easy for you, friends. That's my humble suggestion. Hope this is clear now. Can you please confirm this in the chat box if you are good with default functions? Maybe you can try now the other three problems like triangle, area of triangle. Just only logic that you can get it from Google and just rewrite that logic to suit your this function code. That's all. Anyhow, the triangle function you just put as that triangle func and then rectangle func or like that. You can name like that. Just call that. That logic anyhow we had discussed in the very beginning, but that's a simple logic for all this geometric shapes. This logics are that logic is so simple, friends. You can try, you can give a try for that. Is that good now? Right. This is all about default functions. In tomorrow's session, we'll talk about parameterized functions. Is that clear, friends? So that's the idea. Can you please confirm if you are good? Sunita had tried with input. Yeah, you can. That's a good thing. Yes, that's. So you are able to get the output right, Sunita. Then that should be fine. No issues. All of you are clear on this, what we discussed today, friends? Can you please confirm in the chat box? Yeah, I think you answered. Rita replied back. Thank you. What we do is tomorrow we discuss parameterized and try to come up with more use case with functions on collections we did. We create like, we'll see like how to implement different use cases with functions so that you understand, like playing with those functions as well. Okay, that's all, friends. We'll catch up tomorrow again with the other topic of parameterized functions. Right. Thank you. Any more questions we can discuss? Else we'll stop here. Catch back again. And a small request for you is, friends. I'll share this Google reviews link. Please review. Please share your that reviews, friends, so that it helps us to get that visibility. Right. Thank you. So I'll share the link with you. I just shared with some of our. Yeah, I think this one. So this is the link, friends. Please share your review, your review in this Google thing, Google link, friends. Okay, thank you.